So hello everybody, we are dealing with a very interesting problem. The problem is based on error analysis and it is from IIT JEE Advanced 2016. So let's get started with the problem. The problem is stating in an experiment to determine the acceleration due to gravity, the formula used for the time period of a periodic motion is t equals 2 pi root over 7 r minus r by 5g. The values of capital R and small r are measured to be 60 plus minus 1 millimeter and 10 plus minus 1 millimeter respectively. In 5 successive measurements, the time period is found to be 0.52 second, 0.56 second, 0.57 second, 0.54 second and 0.59 second. The least count of the watch used for the measurement of the time period is 0.01 second. Which of the following statements is or are true? Now we need to check for the error in the measurement of small r, in the measurement of capital T and in the determined value of small g. So for the first few seconds I am spending the time to tell you what this formula is all about. As such, it is not needed to know the whereabouts of this formula, but it's an habit of a physics teacher to do some digging work कि भाई कहाँ से पुराना सवाल आया है उसको पता किया जाए. तो मैं थोड़ा आपको इसके बारे में इंसाइट दे देता हूँ. सो ओवर हियर वी कैन से दैट this particular formula is from if you are looking at a HCV book which you have, so you can look at page number 255, chapter name SHM, and then you can read question number 39, and if you check the answer in the text, this answer is this. So this is the problem which we are solving. So it originated over here, and now we are talking about in detail about the problem. So the problem is technically a spherical ball of mass m and radius r rolls without slipping on a rough concave surface of large radius capital R. It makes small oscillations about the lowest point. We need to determine the time period. So technically we can say that the experimental setup consists of a large curvature wherein we are having a central line like this and a small sphere of a smaller radius is moving in this curved trajectory. So time period of this small sphere in this curvature of radius r will be evaluated as t equals 2 pi root over of 7 r minus r by 5g. So this is the problem which we have, but we are not bothered about all this. We are only bothered about the error analysis aspect. So as I said, I will give you an insight into the problem, and now let us get started with this problem. So the problem is giving us 5 successive measurements of the time period. So if you want, you can work on this problem also, to how to evaluate this thing. If you want the solution to this, you can ping in the comment below. I will give you the solution for this also. So let's get started with this one. So we have 5 time periods in the problem. So I am making a column box over here. So we are having certain readings. We have 5 readings over here as follows. So the first reading is 0.52 second, and we have faith only up to like this digit. 0.01 second is the least count of the instrument. Then we have 0.56 second. The next one we have is 0.57 second. Then we have 0.54 second. Then we have 0.59 second. So if we calculate the t total, so if I mention over here t total, so t total over here turns out to be 2.78 second, and then if we calculate the mean value, then it is equal to 2.78 divided by 5. So if we divide by the number of terms, so we get a value 0.556, but again it must be kept in mind that we cannot take till this third place. So we are writing it as 0.56 second. So this is the mean value. So mean value for all the readings, we are putting it in center over here. 0.56 second is the mean value. Now using this mean value, we are going to calculate the error in each measurement. So error associated in each measurement is t mean minus this value, and we will only take the mod values. So over here we have 0.04 second, the next one is 0 second, then the next one is 0.01 second, then we have 0.02 second, and then we have 0.03 second. So now if we calculate the delta t average, that is the error in each measured value, so the average error is turning out to be, so if we add all the terms, then we get 0.10 second, and then the average value will be sum of this divided by 5. So if we divide this by 5, then we get a value roughly 0.02 second. So this is the value that we have. So over here, if we calculate the error associated with the measurement of time, so error, so this one part of the problem is to determine the error associated with the measurement of capital T. So error associated with measurement of capital T, error associated with capital T value, so we write it as delta T by T into 100, so we will get the values in percentage. So we have it as 0.02 divided by 0.56 and then multiply it by 100, so we get 3.57 percentage. So this is the error associated in the measurement of capital T, and if we go back to this problem, we can say that B alternative is correct. So alternative B is correct. The error in the measurement of T is 3.57 percentage. So in the next aspect, we are also given the values of capital R and small r, but before that let us work on this aspect, that capital T is given to us, so we are interested in calculation of small g. So we can say that from the formulation which we have, that capital T is equal to 2 pi root under 7 times of r minus r by 5g. So and if we square on either side, then we get that t square is equal to 4 pi square, and then we have 7 by 5g r minus r, and then from here if we write the value of small g, so small g can be written as 28 pi square by 5. So these are the digits, and then we have r minus r by t square. So now if we are writing the error in the measurement of g, so we can write it as delta g by g is equal to twice of delta t by t plus delta r plus delta r, so the errors are added, divided by the measured value, that is r minus r. So error in both these terms are added, delta r plus delta r, the measured value will be r minus r. So this is the value that we will using to calculate the value of delta g. So before we go to delta g, let us see the error in the measurement of capital R and small r. So the values of capital R and small r are measured to be 60 plus minus 1. So error in the measurement of capital R is 1, and delta r by capital R, if we do, then we get 1 by 60 into 100. It is not asked in the problem, but small r is asked. So delta of small r is equal to 1 millimeter, and delta small r by small r is equal to 1 by 10 into 100. So we obtain a value 10 percentage. So over here we can say that alternative A is also correct. And now we are going for the jackpot, that is calculation of error in the measurement of G. So if we go for the error in the measurement of delta G, so if we calculate the percentage error, then we multiply this term by 100. So percentage error in delta G by G can be written as twice of delta T by T times 100, this value, and then plus delta R plus delta R. So error in each value is 1 millimeter and then again 1 millimeter. So 2 millimeter upon r minus r, that is 50 times 100, so as to calculate it in percentage. And over here we obtain the value that is twice of 3.57, that is 7.14, and over here we obtain 4%. So we obtain a value 11.14%, which is roughly 11%. So if we check for the alternatives, so error in the measurement value of G is 11%. So we are going with alternative D, and over here we can say that A, B, D are correct alternatives. And this is how we solve this particular problem, which is more than one correct type. So again I am repeating this problem originated in HCV SHM question number 39, where this formula is deduced for the time period of a spherical ball in a cup of radius capital R. So you can draw a tangent over here, consider it as an inclined plane, and solve for this time period if you want. And then you can continue with this problem. To solve this problem, you absolutely do not need from where this formula originated, but maybe for next time, maybe advanced ask you next time to calculate this formula and then come to calculate this particular problem. So for this you can do some research work, basic research work. You can go and solve this problem also, and then maybe come back to attempt this one. So this one we are going with A, B and D. I hope you like the content. Please continue to watch, like, share and subscribe the channel for more such videos.